Hello and welcome to Mathematics with Simon. I'm Simon. Today we are going to look at differentiating quadratics. So here is a quadratic, y equals x squared plus 4x minus 5. We can do this term by term, so we can differentiate x squared, then 4x, then minus 5, and then we can add these three derivatives together. So we saw in the last video that the derivative of x squared is 2x. We did that from first principles. More broadly, the derivative of x to the n is nx to the n minus 1. So what we do is we multiply by the index, then we reduce it by 1. So the derivative of x to the 10 is 10x to the 9. The derivative of x cubed is 3x squared. And the derivative of x to the 20 is 20x to the power 19. So in this case, we multiply by the 2, and then we reduce the power by 1, so the 2 goes down to a 1. X to the 1 is just x, so the derivative of x squared is 2x. Now what about y equals 4x? Well, derivative is the gradient, and this is a straight line, so the gradient is just constant. So actually we can work this out at any point and use any interval. Let's use the whole interval here. So let's use change in x, which is 10. The change in y is 40. So to work out the gradient, we take the change in y, which is 40, we divide by the change in x, which is 10. 40 over 10 is 4. And also we remember that for straight lines, y equals mx plus c, and m is the gradient. So here, y equals 4x plus 0. 4 is m. 4 is the gradient. That's why dy by dx equals 4. So this all makes sense. If y equals 4x, dy by dx equals 4. If y equals 5, then dy by dx equals 0. So there's no change. It's a constant function, so the gradient is 0. Another way of thinking about it is you can think about y equals mx plus c here. So here, c is 5, that's the constant, and actually m is 0. This is y equals 0x is plus 5. So again, that's another way of working out that the gradient is 0 in this case. So we're thinking about our quadratic term by term. Differentiate x squared is 2x, and then 4x goes to 4, minus 5 goes to 0, and then we can add the 3 together. Now for the advanced students, why are we allowed to do this? Why are we allowed to add them together? I'd love to know what you think. Please post in the comments. It's actually quite a sophisticated question, because it's not true of a product. So if y equals u times v, you can't just differentiate u and then times it by the derivative of v. But you can do it with sums and with differences. So the question is why. So here we are, y equals x squared plus 4x minus 5. We take the derivative of x squared, which is 2x. The derivative of 4x, which was 4, the derivative of minus 5, which was just 0, so that drops off. We get 2x plus 4. It looks like this. This is a picture of the curve of y equals x squared plus 4x minus 5. This is it. We can spot some things. Firstly, here, the derivative is 0. So when we put minus 2 into 2x plus 4, we get minus 4 plus 4, which is 0. Where the derivative is 0, the curve goes flat, and this is actually a minimum point. So the curve is flat here, it's a minimum point. And if we want to find the minimum points of a function, we need to find the points where the differential is 0. So that's an interesting thing to do. Indeed, if you want to find the maximal points, we do the same thing. The difference between the two is the second derivative, which we'll come to in future videos. Also, just out of interest, the curve crosses the x-axis here, where x equals minus 5. So if we put minus 5 in, x squared plus 4x minus 5 is 0. So you put minus 5 in, minus 5 squared is 25. Then you get minus 20, minus 5 gives you 0. But also we can see a second point where the curve touches the x-axis here. This is where x equals 1. If you put 1 in, you get 1 plus 4 minus 5, which is also 0. I hope you've enjoyed this and you're having a great day. If you have, please hit the like button. If you want to see more in the future, please hit subscribe and the notification bell. I hope you enjoy your mathematics, and I really look forward to seeing you next time.